All right, we're on to the Grandmaster video for Chapter 6, Section 5. We're going to talk about vertical lines. We've talked about lines with positive and negative slopes, and we've talked about lines with a slope of 0, and they were horizontal. But what about lines that are perfectly vertical? Okay, now I could tell you, but I think it'll sink in better if you actually see the problem that we run into. So let's use the formula from the previous video to determine the slope of the line. So I don't really care. I'll choose this as the second set. So this is my x2, y2, and this is going to be my x1, y1. Okay? So our formula is slope equals y2 minus y1 over x2 minus x1. Okay. Well, what is our y2? Well, that's up here. The y coordinate is 7 minus y1 right here. That y coordinate is negative 5. So 7 minus negative 5 over x2 minus x1. Well, x2, that's this x coordinate, that's 5, and x1 also has the same, so it's 5 minus 5. So what do you get when you work this out? 7 take away negative 5 is 7 plus 5, which is 12. But 5 take away 5 is 0. So we have 12 over 0. That's a problem. Okay. What is the problem, or why is it a problem? It's because 12 divided by 0 is undefined. You cannot divide numbers by 0. Try it in your calculator. It'll give you an error. Okay? So what's the slope? Well, that is the answer. The slope of any vertical line is undefined. Okay? Because when we try and substitute numbers into the formula, we always get a 0 in the denominator. And that's because if it's vertical, the x-coordinates are always the same. So any number take away itself is going to give us 0. Okay? So the slope of any vertical line is undefined. All right, moving on to some critical thinking problems. First off, we have a line, and we are told it passes through x equals 5, y equals negative 3. But we're told that its slope is negative 4. Well, if you're wondering what that means in terms of rise over run, remember that negative 4 mathematically is the same as negative 4 over 1. Okay, so you can think of your rise as negative 4 and your run as positive 1. All right. So let's first plot our point, because then we know our line has to go through there. So 5, negative 3. There it is. So we have to draw a line that passes through this dot, but has a slope of negative 4 over 1. Well, this is our rise, and we know that if this is negative, we move down. Okay, so from this point, we count down 4 spaces, and then this tells us we have a run of 1. So we move to the right 1 space. So we go down 1, 2, 3, 4, and then we move to the right 1. So we know that another dot on our line would sit there. Let's try it again. 1, 2, 3, 4 over 1, and there we go. So you can see these 3 dots would form a straight line. And we know that mathematically, isn't negative 4 the same as positive 4 over negative 1? Okay? Remember I said the negative could go either or. So from our original starting point, if my rise is positive 4, that means I go up. 1, 2, 3, 4. But my run is negative 1, which means I go left. So as you can see, it doesn't matter. All of these dots will still fall on a straight line. So I think I have enough now. I will draw it in as best I can, somewhere like that. Perfect. There we go. And of course this continues on. Okay, so there's our line. You can check, but it has a slope of -4 or -4/1, and it passes through the desired point of 5, -3. So there we are. All right, last problem. We have 2 points that a line passes through are expressed algebraically as -4x, 7x squared, and 8x, 15x squared. So these are coordinates, but they're not defined precisely. They are algebraic expressions. But nevertheless, we are asked to determine the slope. And we're probably going to have variables in it, but we're going to simplify it as much as possible. Okay, so imagine these are 2 points. We just don't know them precisely. So it doesn't really matter, but you can think of this as x1, y1, x2, y2. There you go. So now that we've established that, remember the formula for slope is delta y over delta x, or y2 minus y1 over x2 minus x1. Okay, so let's start filling in what we have. y2 was 15x squared minus y1, that is 7x squared, over x2, that is 8x, minus -4x. So you got to be careful here. You're minusing, you're subtracting a negative. There we go. All right, so we have a bit of an algebraic mess, but we're just going to simplify it as best we can. So we look at the numerator. We have 15x squared minus 7x squared. Those are like terms because both terms have an x squared in it. So that gives me 8x squared. You should be familiar with that. And the denominator, 8x take away -4x. Well, that's the same as 8x plus 4x. And again, we have like terms. So that would give us 12x. There we go. It's a bit better. But we can simplify it still. Okay. Let's look at the numbers. 8 over 12. Okay. The greatest common factor there is 4. Okay. So that gives us 2 over 3. Okay. 8 over 12 is the same as 2/3. But now we need to reduce the x's if possible. Remember, x squared means x times x. And x, well, that just means x to the 1. So if you think about it, x squared over x, what that means is x times x over x. So one of these x's cancel out. So I'm actually just left with 1x in the numerator. So there we go. That's our slope. Okay. You can express your answer like that, or another way is perfectly acceptable. If you have a variable in a fraction and it's in the numerator, you can float it in the middle to the right. So it could be written like this. Okay. It would be completely incorrect if you put this in the denominator, though. So the variable can go in the numerator or in the middle, but not in the denominator. So there we go. That's our slope.